So hello everyone, in this video I will explain regarding the gradient that I have explained before. So in the previous meeting I told you to do the number 2, right? For example, I took the complex number here in number 2. Let me just discuss again with you for number 2D. We have y equal 1 over 2x to the power of 2 plus 3 over 2x at the point 1.2. Okay, so remember the question is want us to find the gradient. Remember I told you before that the gradient, we can find it, the gradient of the curve actually is the gradient of the tangent, right? At the specific point of tangent at the specific point. Okay, how can we find this value, the gradient of the tangent and also the gradient of the curve? Actually, we can find it through limit, or we can find it through, what do we call it again? Yes, derivative of or differentiation. Okay, so to make it more easy for us to find, let's just use the differentiation method, right? So actually to find the gradient, we can say that actually we have y-axis, or this is the symbol of the differentiation, y-axis, and then also dy dx, and then what else, f-axis y. Actually those are the same using the differentiation, because that can be used to find the gradient, which is gradient symbol here is m. So actually I can do it like this, I can write it like this, right? After that, if I am going to find the y-axis or the gradient, then I only find the gradient or the y-axis value. How can we find the y-axis value? Remember, the power we multiply it by 2, and then we the power of 2 we multiply it with 1 over 2 right there. Okay, so 2 times 1 over 2, and then the x, still x. After that, the 2, the power, we need to remember to subtract it with 1. That's why in Indonesia we called it as turunan, right? I have explained this before. I told you that in Bahasa Indonesia we called it as turunan. Why? Because the power actually, it's the deducted 1 point, like that. This one, 3 over 2 multiplied by 1, and then here x, this becomes 1 minus 1. So here 2 cancel by 2, x to the power of 1 only, and then here 3 over 2. This is the y-axis. I told you it's actually the same with the gradient, right? Because we have specific point here, which is 1.2, which is this one is y, this 2 is this one is x, and the 2 is for the y. And actually we can just substitute the value of x with 1, and then 1, right? Yes, correct. Plus 3 over 2. Remember that this y-axis is not this y. Okay, it's not. What is this y-axis? Y-axis here is the gradient already. Okay, so all we need is just to substitute the value of x, which is here 1, so that we will find out the gradient of this line is actually 2 over 2 plus 3 over 2. Why becomes 2 over 2? Because 2 over 2 is 1, yeah? I think that's clear already. 2 plus 3, this is 5 over 2. Then this is gonna be the gradient of the line. Another question that I told you to do is number 8 right here. A curve has equation y equals 12x to the power of 1 over 2 minus x to the power of 3 over 2. Find the dy dx. Later on, the final answer will be 3 over 2x to the power of minus 1 over 2, 4 minus x, like that. Okay, then let's find the dy dx. It's going to be this 1 over 2 multiplied to 12 x 1 over 2 minus 1. Here 3 over 2 multiplied by 1 x 3 over 2 minus 1. So the dy dx will be 12 divided by 2, 6. So 6x 1 over 2 minus 1 is minus 1 over 2. Where is that value from this one? 1 over 2, we have minus 2 over 2, minus 3 over 2, this one also 3 over 2, minus 2 over 2, so it's gonna be dy dx equals 6x to the power of minus 1 over 2 minus 3 over 2x 1 over 2. Okay, it looks like different, but actually we can do factorization so that we can find the final answer. Okay, then let's try. Dy dx is equal with 3 over 2x minus 3 over 2. Here 4 minus x. Okay, let's try. If we multiply 3 over 2, we will come up with the times 4. This is 2. 2 times 3 is 6. So we will get 6x to the power of minus 3 over 2. Oh, sorry. That is not 3 over 2. This is 1 over 2. Okay. And then after that, if we expand again the 3 over 2 right there, we will come up with value 3 over 2x to the power of minus 1 over 2 plus, because we multiply, it becomes like plus like this. And then we will come up with the value 1 over 2. Okay, so actually this final answer, the factorization form of the dy dx that we got earlier. So we can do it like this only. Then we will come up with the final result like this. Then done. Okay, so we have right here part A, part B from number 8. Find the coordinates of the point on the curve where the gradient is 0. Remember, gradient meaning the first derivative. So because we have here gradient equal to 0, so I have here, I need to write m equal to 0, and then we're going to find the coordinates of the point, meaning we're going to find the specific point, which is x and y. Okay, after that, we have found already the first derivative on the first part, which is the part A. The y-axis is actually 3 over 2 x to the power of minus 1 over 2, 4 minus x. Okay, so remember the gradient of the curve at the specific point, we can find it using the derivative, right? So if we have this gradient is equal to 0 already, then we can substitute the value of 0 in the y-axis or in the dy dx. These two are the same. Do not be confused. These two are the same. Okay, the symbol is different, but they are the same. Remember that. Okay, so we have gradient equal to 0, and then here 3 over 2x to the power of minus 1 over 2 This is 4 minus x. Okay. After that, this is, remember, this is already the factorized value. So if it's factorized value already, if we are going to find the x, then we just need to make it equal of 0, both of them. 4 minus x equals 0. In another part, we have 3 over 2 x to the power of minus 1 over 2 equals 0. Okay, so how do we find the x right here? Remember, what is the value that if you substitute, or what is the unknown value if you subtract the 4 with that value, will come up with 0. 4 minus what value will come up with 0? Yes, correct. That is 4. So that's why x is gonna be 4. Only 4. Next. For this part, 3 over 2 x to the power of minus 1 over 2, so that it will make us easier to find the x. We need to change it first into the non-exponential form. How to change it? Like this. 3 over 2 root x squared. Okay, like that. Equal to 0. Okay, so now how do we find the x? Okay, this one left here becoming 0 times 2 over 3. Okay, this one becoming 0 still. But then the next problem, 1 over root x is equal 0. What is the x value right there that can we make equal to 0? What is it? There is none, right? There is none, of course, because there is none. That's why here it becoming x is undefined value. Okay, so actually the one and only x that we have is only 4. Okay, so after that, we find already x equals 0, then we will use it in order to find the y. Remember the original y, the original function that that given from this question. We have y equal 12x to the power of 1 over 2 minus x to the power of 3 over 2. And then all we need to do is just to substitute the value of x equal to 4. So we make it here root 4. Here we make it 4 root 4. Okay, so this is actually 12 root x minus x roots x. Okay, like that. Okay, so after that, here becoming 12 times 2, here 4 times 2, here 24 minus 8, so y it's gonna be 16. So the final coordinate point is 4.16.